In this video we will solve probability questions which have been already asked in GATE exams earlier. We will try to, this is part 1 of the 7 parts. In each part we'll try to solve some 10 questions, so that by the end of this series we will have solved some 70 previously asked GATE probability questions. This will also give us a very good insight of what standard of questions are being asked in the GATE exam, and also this you can also use for revision and for making your own notes, right? So people who have some fear of probability for the GATE examination, I think this 7-part series will be very good for your notes preparation. So let's move ahead here. Now question number 1, a fair die is rolled twice. The probability that an odd number will follow an even number is. Now, probability of an event E is described as favorable cases. Favorable cases by total cases. Now, suppose a die is, what are the outcomes? 1, 2, 3, 4, 5, 6. Suppose die 1, we have thrown another die. Die 2, what are the outcomes? 1, 2, 3, 4, 5, 6. Now, the question is, probability that an odd number will follow an even number. So, probability of odd is what? 1, 3 and 5, right? This is what? 1 by 2. Means it is like 3 by 6, which is equal to 1 by 2. Now probability of even is what? 2, 4, 6. This is also what? 3 by 6. Why 6? Because there are 6 possible outcomes, right? So is equal to 1 by 2. So now the answer to the question, probability of odd followed by even. Why even? What is odd is 1 by 2 into even. What is even? 1 by 2 is 1 by 4. The answer to this question is option D, 1 by 4. I hope this was well understood. Now, the probability density function is of the form P of x is k e power minus alpha mod x. The value of k is. So first of all, modulus function. Mod x is equal to x if x is greater than 0 and it is minus x if x less than 0. This is the definition of mod function. Okay, so this is what a mod function is. Now we know for a PDF minus infinity to infinity f of x dx is always equal to 1 minus infinity to infinity. This is the definition. So now we can write like this, minus infinity to infinity. Why? Because this is a probability density. K e power minus alpha mod x dx is equal to 1. Now what? Now you can split it. K, if you take minus infinity to 0, k e power minus alpha mod x dx plus k into 0 to infinity e power minus alpha mod x dx is equal to 1. So this is how we can write. Now this is the first part, this is the second part. Okay, now see, as I told, from minus infinity to first part, what is it? Minus infinity to 0, k e power minus alpha mod x dx. This I can write, see, minus infinity to 0, okay, mod x will become minus x. See, when x is less than 0, it is minus x. So this I can write as minus infinity to 0, k e power minus alpha into minus x. So this will be equal to minus infinity to 0, k e power alpha x. The first part. This is for the first part. Okay. Now second part. Second part is 0 to infinity k e bar minus alpha mod x. Now for 0 to infinity, meaning x is greater than 0, mod x is x only, so you can write it as 0 to infinity k e bar minus alpha x. Okay, so this is the second part. Now this first part I will replace with this, the second part I will replace with this, and then we will have to integrate. Let us see the next slide. I copied these two terms from the previous slide. Now first term and second term, these are like this. Okay, this is plus actually, so I can write it like minus infinity to 0 k e power alpha x plus 0 to infinity k e power minus alpha x dx is equal to 1. So e power alpha x by alpha, this we already know, this is minus infinity to 0, k I have taken outside, plus k e power minus alpha x by minus alpha 0 to infinity is equal to 1. So I can write k into anything power 0 1 minus e power minus infinity 0 by alpha plus k into e power minus infinity 0 minus anything power 0 1 by minus alpha minus this is alpha is equal to 1. Okay, this is infinity, this is alpha. Now this is what, k by alpha plus plus k by alpha is equal to 1. So write 2k by alpha is equal to 1. So k is equal to alpha by 2. This implies k is equal to alpha by 2 is equal to 0.5 alpha. So k is equal to 0.5 alpha. This is the answer. Now note, okay, this is a very important model, very important question from GATE perspective. From GATE perspective, why I am saying, because many questions have been asked in this model, that when we have a PDF, then minus infinity to infinity f of x dx is equal to 1, there will be a term, there will be a constant like k, and whose value will be asked. So I hope this was understood. The answer to this question is 0.5. Now question number 3. This is very simple, just we have to understand. See, 3 companies XYZ supply computers to a university. Okay, there are 3 companies. The same table I am writing it in another way. Okay, I have X, I have Y, I have Z. Okay, this is percentage supplied. X supplied what, 60, Y supplied 30, these are all percentages. Okay, and Z supplied 10%. And defect for X is 0.01, 0.02 and 0.03. Okay, now the question is, given that a computer is defective, we know that the computer is defective, the probability that it was supplied by Y, probability that it was supplied by Y. Yes, how do we write? See, probability that it was supplied by Y. See, it was supplied by Y and it was defective, so it will come. So 30% is nothing but 0.3, right? So 0.02 into 0.3 by, we want by Y, right? By total, right? Okay, so by X, what is X? 0.01 into 0.6 plus 0.02 into 0.3 plus 0.03 into 0.1. If you solve this thing, right, the answer to this is 0.4. Fourth option is the correct one. See, this is like how do Bayes theorem and total probability concept. Okay, so first of all, the same, what is the question? We have written the same thing like this. Okay, now what he's telling, we have taken out a computer and it is defective, and he is asking what is the probability that it was taken out by Y. By Y, when we say, so Y should be on the numerator and the remaining L, this is the denominator is total probability, and this is actually a concept from Bayes theorem. Okay, very important concept. So in probability, this is also very important. Bayes theorem and total probability. I hope this was understood. Okay, right. This is question number 4 of the 10 questions which we are solving. Now, what is the question? If E denotes expectation, the variance of a random variable x is given by. See, first of all, the answer to this question, variance of x is given as E of x square minus E of x whole square. The answer to this question is A, option A. Okay. First of all, expectation of x is what? It is defined as minus infinity to infinity x into f of x. What is E of x square is equal to minus infinity to infinity x square into f of x. E of x or E of x square is nothing but you just take an integral and multiply it with x if it is E of x. E of x square means this. Now, as we already discussed, variance of x square is E of x square minus E of x whole square. This you can also write as integral minus infinity to infinity x square into f of x minus integral x into f of x. This is whole square. Right? So this is the thing. This is a very important question, and this will be asked. This is a standard definition. E of x square minus variance is E of x square minus E of x whole square. Okay. Yeah, and expectation is x into f of x. Right? I hope this is well understood. This is a straightforward question. Now let us see this question. This is on the concept of conditional probability. Conditional probability. Let us see first of all what the question is. Okay. In an examination consists of two papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3 and that in paper 2 is 0. This is what? Probability of failing. Given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. What is the probability that the student is failing in both the papers? So before doing this, okay, we will see some concepts. Okay. Probability of event A given that B has already happened is written like this: P of A by B. Probability of an event A given B has already happened is given by this, and it is also written as probability of A intersection B by probability of B. Okay. Also, we can write the same thing as, if suppose probability of B given that A has already happened is given by probability of B intersection A intersection B, or both are same, by probability of A. These are the two formulas I think which everybody should know. And this is what concept of conditional probability. Why conditional probability? Is because we are talking about condition of B happening or A happening after one of them. This first equation is condition of A happening after B has already happened, and the second equation is condition for B happening after A has already happened. Okay. Now, here in the question we can see that given a student has failed in P2, the probability of failing in P1 is 0.6. This, how can I write this? I can write as probability of P1 intersection P2 by probability of P2, right, is 0.6. Now, probability of failing in both is meaning P1 intersection P2. Now, from this what I can write? From this I can write that probability of P1 intersection P2, that means is equal to 0.6 into probability of P2. That is nothing but 0.6 into probability of P2. Failing in P2 is what? 0.2. Is 0.12. The answer to this question is C. I hope this is understood. Now let us see this question. A fair coin is tossed 10 times. Okay, coin is tossed. When a coin is tossed, fair coin is tossed, there are two possible outcomes. Head, tail. Probability of head is 1/2. Probability of tail is 1/2. A fair coin is tossed 10 times. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has been tossed 10 times. What is the probability that only the first two tosses will yield heads? These two are heads. These are tails. Now the probability of head is what? 1 by 2. Here also 1 by 2. 1 by 2. And what a tail? Even head, tail, everything is 1 by 2. 1 by 2, 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 and 1 by 2. Now the answer to our question is here 1 by 2 into 1 by 2. Okay, and this is like 8 times, right? 1 by 2 whole power 8. So 1 by 2 whole square into 1 by 2, 8 is what? Now whole power 10. The answer to this question is C. Okay, I hope this is understood. Now this question is similar to what we have already seen earlier. See, as I have already told, like minus infinity to infinity is equal to 1. Okay, this what we can do now. This we can divide it into two parts: minus infinity to 0 f of x dx plus 0 to infinity f of x dx is equal to 1, and then try to solve. Okay, now same thing if we do. So it's like minus infinity to infinity m e power minus 2 mod x minus n e power minus 3 mod x. Now this is the function. Now if we divide it into two parts, let us see what happens. Minus infinity to 0 m e power minus 2 mod x minus n e power minus 3 mod x. Okay, plus 0 to infinity m e power minus 2 mod x minus n e power mod x dx is equal to 1. Now see how it will change. As I earlier told, mod x is equal to x if x is greater than 0 and is minus x if x is less than 0. Okay, now it is minus infinity to 0 means x is less, right? So what we can write, m e power minus 2 into minus x minus n e power minus 3 into minus x plus 0 to infinity. For 0 to infinity x is positive, so m e power minus 2x minus n e power minus 3x dx is equal to 1. Now what is the like final equation? M e power 2x minus n e power 3x dx plus 0 to infinity m e power minus 2x minus n e power minus 3x dx is equal to 1. Now this is the final equation. We will now solve this to derive the thing. Okay, this kind of questions are all the same. Integral minus infinity to infinity f of x dx is always equal to 1. If there is mod involved, modulus involved, mod function, then what you can do? You can divide minus infinity to 0 and 0 to infinity and then try to solve. In the next slide, we will solve this equation. There is a small this thing that this is minus infinity to 0. Okay, like minus infinity to 0 m e power 2x minus n e power 3x dx plus 0 to infinity m e power minus 2x minus n e power minus 3x. This is if I integrate, this is what e power 2x by 2, right? Minus infinity to 0 minus n into e power 3x by 3 e power minus 2x by minus 2. This is 0 to infinity. This will be what m into this is anything power 0 is 1, right? 1 minus e power minus infinity 0 by 2 minus n into 1 minus 0 by 3 plus m. Anything e power minus infinity 0 minus 1 by minus 2. 2n/3. So this is the answer. So this is how we will solve this question. Yeah, and I hope this is understood, right? All these equation. See, e power minus infinity is 0. Anything e power 0, anything power 0. A power 0 is 1. 100 power 0 is always 1. Anything power 0 is 1. E power minus infinity is 0. So that I have just plugged in, and this is the answer. This question is a question about sample space. Okay, a fair coin is tossed independently 4 times. The probability of event, the number of times heads shown up is more than the number of times tails shown up. Now see, probability of an event E is given by favorable cases by total cases. Okay, now 4 coins are tossed. Okay, so here there are two possibilities. Here two possibilities, heads or tails. Heads or tails. Similarly, heads or tails. Heads or tails. Heads or tails. 2, 2. Okay. What I can write, it is 2 power 4 is equal to 16. So sample space will have 16 outcomes. Okay. Similarly, suppose 3 coins are only tossed. 2, 2, 2 is what? 8. 8 in sample space. Okay. Suppose only 2 coins are tossed. This is 4 coins. Till now we have not gone into the question. These are some basics which I just want to tell before going. This is for 3 coins. What if only 2 coins? Heads or tail? Heads or tail, right? This is 2 ways, so total 4 ways. What are the 4 ways? Head, 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 tail, tail, head, tail, tail. When 2 coins are tossed, these are the 4 ways. Now what about 3? 3 coins are tossed. See, it can be head, 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 tail, head, 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 tail, head, 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 tail. Similarly, tail, 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 head, tail, head, tail, head, tail, 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 head. See, 1, 1, 2, 3, 4, 5, 6, 7, 8. These are the 8 possibilities. Now, these were for 2 coins tossed and 3 coins tossed. Now we have to see, as in the question, 4 coins tossed, what are the sample space? Then we will be able to answer this question. See, here I have done nothing. How to write this thing is, first you put all head, head. Okay, first one. Then traverse tail. Traverse the tail. First tail, here tail will come here, tail will come here. Then all 3 tails. First head, second head, third head, like this. So yeah. Now, we want heads is more than tails, right? This is the condition which we want. Now, suppose we have 4. Okay, heads, 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 heads. Then will be total 2 power 4 is equal to 60 outcomes, as we already saw earlier. Now, what are this? These heads, okay? Now, tail, head, 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 tail, head, 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 tail, head, 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 tail. Similarly, I can have all tails, head, tail, 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 head, tail, 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 head, tail, and tail, 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 head. Now we can have head, head, tail, tail also, right? Then we can traverse this head, tail, head, tail, head, tail, tail, head. Correct, right? Similarly, I can have tail, tail, head, head also. Then I can traverse tail, head, tail, head, tail, head, head, tail. So how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16 outcomes. Generally, they will ask for 2 coins, 3 coins, and max 4 coins. If there are 5, means 2 power 5 possible outcomes will be there, and means that is generally not asked, but yeah. So then time 2.5 outcomes. This is how much? 2 power 5 is, I think, 32, right? So outcomes. But generally up to 4 coins everybody should know. Now heads is more than tails. 1, 2, 3, 4, 5, right? Here tails are more. Tails are more. Tails are more. Here these 6 heads equal to tails, right? So the probability heads are more than tails. How many? 5 only, right? 1, 2, 3, 4, 5. So 5 by 16 total outcome. So the answer to this question is 16. So in order to answer this question, the thing is you should know how sample space is written. So this is very very important for 2 coins, 3 coins and 4 coins at least. So once you know the sample space, then you can write. The thing is, no, first I have written all heads, then I have put one tail, and then see tail first, tail second position, tail third position, tail fourth position. Similarly, all tails, head first position, head second, head third, and head fourth position. This is how you write the sample space. Then here head, head, tail, tail. Then this head I am traversing. This head was second position, third position, fourth position. Similarly, tail, tail, third position, second position, tail, third position, last position, tail. So this is how you do it, right? I hope this is understood. Now, ninth question. In a manufacturing plant, the probability of a defective, okay, defective, I am writing a P is 0.1. If P is 0.1, Q is what? 1 minus 0.1 is what? 0.9. This is what? Binomial distribution. So P is equal to 0.1, Q is equal to 0.9, N is equal to what? 900. Mean is what? Formula for mean is NP. Variance is NPQ. What about standard deviation is root of NPQ. Now N is what? 900 into P is 0.1, right? This is what? 900 into 0.1 is 90. And what about this? 900 into 0.1 into 0.9. What about this? 900 into 0.1 into 0.81. This is 81. But what we want? We want standard deviation is root of 81 is 9. So mean So I hope this is understood. Yeah, this is binomial distribution directly, and these are the formulas, right? So you know, right? Binomial distribution P of x is equal to R, NCR, P power R, Q power N minus R. This is the formula where mean is NP, variance is NPQ. Yeah, I hope this is understood. Now, last question in the first part out of 7 parts. Okay, consider the continuous random variable but probability distribution function, this the standard deviation. Okay, what we earlier studied is variance is e of x minus e of x whole square. Now what is e of x square? Is x square into f of x minus, this is what? Integral x into f of x whole square. Now we will first of all see this. Okay, expectation of x is minus infinity to infinity x into f of x, right? Standard deviation is what? Root of variance. Okay, so we will find first of all this, and then we will find the square root of that, and then we will get the standard deviation. That is the procedure. Okay, now this I can write as minus infinity to 0 x into f of x plus 0 to infinity x into f of x. I am finding the mean part, e of x part. Now if I write it is like minus 1 to 0 is what? 1 plus t. Okay, t into plus 0 to 1 t into 1 minus t dt. Okay, Now if you do what, minus 1 to 0 t plus t square plus 0 to 1 t minus t square dt. Now t square by 2 plus t cube by 3 minus 1 to 0 plus this is what, t square by 2 minus t cube by 3, this is from where, 0 to 1. Now this is what, 0 minus of 1 by 2 minus 1 by 3 plus this is what, 1 by 2 minus 1 by 3. Now if you see, it is 0. So this part, so expectation is 0. So this part is actually, so in the variance is equal to e of x square minus e of x whole square. This part is 0. Now what I have to find? Now my find is variance is e of x square. This I have to find, and then I will have to do the square root of it to get the answer. Let us find that first. Yeah. Now this was the function. What I have to find? I have to find now e of x square. That is nothing but minus 1 to 0 t square into 1 plus t plus 0 to 1 t square into 1 minus t minus 1 to 0 t square plus t cube plus 0 to 1 t square minus t cube dt. Now this is what, t cube by 3 plus t power 4 by 4 minus 1 to 0 plus t cube by 3 minus t power 4 by 4 0 to 1. Now this is what, this is 0 minus this was for upper bound. Now lower bound is what, minus 1 by 3 plus 1 by 4 plus 1 by 3 minus 1 by 4. So this is what, see, this is 1 by 3 minus 1 by 4 1 by 3 minus 1 by 4. This is what, 2 by 3 minus 1 by 2. This is what, 4 minus 3 is 1 by 6. So variance of x is what, 1 by 6. What we want, standard deviation is 1 by root 6. So the answer to this question is 1 by root 6. Yeah. So this is the end of the first part out of the 7. So yeah, so I will just conclude this thing. So this is the conclusion slide. So what we have, so this is conclusion slide. So till now what we have seen, one thing is PDF is nothing but minus infinity to infinity f of x dx is equal to 1. So questions on this will be definitely there, like there will be some constant and you will have to find the value of that constant. So you can use this formula to do that. Next thing is expectation of e of x is what, integral minus infinity to x into f of x. Similarly, if someone asks you to find e of x square is what, integral minus infinity to infinity x square into f of x dx. What is variance of x? Variance of x, e of x square minus e of x whole square. This is variance. What is standard deviation is nothing but root of variance. We also saw binomial distribution. What is binomial? P of x is equal to r is given by NCR p power r q power n minus r. If the question comes, I will explain it well. Where mean is what, np, and variance is what, npq, and what is standard deviation is equal to root of npq. Okay. What is definition of probability? Probability is nothing but favorable cases by total cases. Here we have seen 10 questions. This is the first part. We will see some 7 parts. We will cover some 70 questions. What I'm saying is, by the end of this video series, at least some knowledge will be there. These are all previous GATE questions, so you will also understand what is the standard of the questions at least, right? So these are some things which I wanted to say. Yeah, thank you very much.